Hello everyone, welcome back to Advent of Code 2025. Still slowly catching up to live. Spent a lot of time yesterday on problems of my own making, which was somewhat intended and somewhat not. Let's get going with day 7. Laboratories. You thank the cephalopods for the help and exit the trash compactor. Brand new sentence, I guess? Finding yourself in the familiar halls of a North Pole research wing. Based on the large sign that says Teleporter Hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto the large yellow teleporter pad. Suddenly, you find yourself in an unfamiliar room. The room has no doors. The only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. Since this is a teleporter lab, there are lots of spare parts, manuals, and diagnostic equipment lying around. After connecting one of the diagnostic tools, it helpfully displays error code, "Oh no!" which apparently means that there's an issue with one of the tachyon manifolds. You quickly locate a diagram of the tachyon manifold, your puzzle input. A tachyon beam enters the manifold at the location marked S. Tachyon beams always move downward. They pass freely through empty space, but if it encounters a splitter, the beam is stopped. Instead, a new one continues from the immediate left and from the immediate right of the splitter. Okay. So what happens when two beams are in the same place? They're both dumping tachyons into the same place, so only, like, this one doesn't count twice. There's only one of them. So we're asking how many spaces has a tachyon ever visited, basically. This process continues until all the tachyon beams reach a splitter or exit the manifold. You need to understand the beam splitting property of the tachyon manifold. How many times will the beam be split? So you do kind of have to track I was thinking at first you could just count for each space how many times a tachyon beam has gone into it. But that double counts all of these spaces, right? Like this one's visited 2 times, but we're only supposed to count one of them. But that's fine. We could still count it as 2 if we wanted. And then just say how many spaces have been visited at least 1 time. And that way we'd have both pieces of information. However, this is a very exponential looking process. And I suspect that the actual input, if we tried to track each beam individually, yeah, I mean, there's 140 rows that are mostly full of tachyon splitters, right? Like, there's some gaps, but most paths that a beam could take, it splits every row. So we're looking at something like 2 to the 140th separate possible paths, right? Or, well, 2 to the 70th, because it looks like the splitters are only every other row. And that's still way too big. We can't track them all individually. We have to track them together. So, what's the right data structure for this? Obviously, an array is okay, but I don't think it's really necessary. Our data is quite sparse. There's a lot of places where there are no Um, there's a lot of spaces that are empty. So we could have like a map of coordinate to Boolean, whether there's a splitter, or, you know, maybe coordinate to like a data structure that's, is there something here? Is it the start, or is it a splitter, or is it nothing? But that has a slight problem, not a huge one, but that it's sort of hard to tell, have we gotten to the end of the data structure? We don't have like, well, I mean, what I was going to get to next was maybe we should have a map where the key is a row number and the value is another, like a set, indicating which columns within that row have a splitter in them. And then we could say, oh, what is the max key of this map? Which would tell us the last row that has a splitter in it, and if our current row is past that, we could stop looking for splitters. But that's not actually any better than just having a single map, because a pair is also sortable, and we can also ask, like, you know, is our, like, suppose we're tracking a beam that like starts, we're on this row or something. We could construct the coordinate like 140, 0, just like it shows here, 143, 0, and say, are there any entries in the map larger than that? The answer would be yes. There's ones down here at 140. Oh, whoops. This was 140. This is 141. Okay. Yeah, there are some at 141, 1, and that would be bigger because we sort pairs by their first element first. And once we get down here, we would say, are there any larger than this? And it would say no. So we could just use a map, or I guess rather even a set of coordinates. And implicitly, like if there's something there, it's a splitter. But maybe a set isn't quite what I want, because I have to track other information about the splitter, namely whether it's been visited by a beam, right? So we want a map where the key is a position and the value is data about the splitter at that position, and where places there is no splitter, there just won't be, that key won't be present in the map. That way, I think it would be reasonably simple to traverse, like to draw out all the traces. We could even do it one at a time. You don't have to like start with one beam here, and then once it's here, like track the one that shows up here and the one that shows up here in at the same time, or I guess here and here. You could just like say, all right, I'm going to keep tracking this one on the left. I'll put these both in the queue of like traces to track. And then when we get here, it'll split, and I'll have three things in the queue, right? The one that went here, the one that went here, and the one that's still up here. This goes down, we split again, and there will briefly be four. I mean, you could do it a little bit better, Yeah, I guess because instead of having a queue of things to track, you could keep a set of things to track. That's probably better, but not in a very important way. And finally, when we get to this splitter is the first time we'll have to do something interesting, which will be if we take a beam off of the queue, or the pending set, or whatever, we'll look at the position it's at, and if it is at a splitter we've already visited, we'll throw it away and grab another one off the queue. And that way we only track one of the two paths through this thing. And in fact, if we only move each beam by one step before we put it back on the queue, we don't have to worry about like, oh, keep moving until you hit a splitter or whatever. And we'll even trace them all like row by row because we'll be pulling them off the set in a row order. So like the topmost leftmost beam will always be selected. So we shouldn't run into... We shouldn't ever be keeping any duplicate beams around longer than we have to, I think. This seems nice. Okay. So a map from position or coordinate or whatever to data about the splitter, which for now just seems to me like it should keep a Boolean whether it's been visited. You know what, though? I would not be at all surprised if part 2 says, actually, we want you to treat, like, when a beam goes from here, or from up here to this spot and this spot, and then those both go to here, we want you to treat this as one beam, and this as two beams, and this is one beam. Right? Actually count the number of times any beam is split. What's the current wording? They're both dumping tachyons in the same place. Between them, they create only 3. But I wouldn't be surprised if part 2 says, no, you should count this beam twice. And that's something that, if I'm not careful, I could make it difficult to do. By just throwing away data. But if I make... Like, I could just do what I guess part 2 might be as part of doing part 1, and it wouldn't be that hard. And then if part 2 is to do that, great, I'm pretty much done. And if it's something else, I haven't wasted that much work. Because I could easily associate with each pending beam a count of like how many real beams this virtual beam represents or something, right? And track at each splitter, not just has it been visited, but how many virtual beams have visited it. Or how many real beams have visited it, excuse me. And then at the end, I could just count up how many of them... Wait, that might make it hard to recover the data for part 1, actually, if I did it that way. Would it? No, because... a splitter... can only ever be visited by one of these virtual beams, I think. I don't think there's any way, because if it was all happening kind of simultaneously, the only way to get two things to visit this is to have them split from something above it to the right and above it to the left, and that just counts as one. So if I count up virtual visits, I'll have some number, and then at the end I can just say, is that number 1 or 0? I think that's true. And I guess I don't want a visited set anymore either. I want, or not a pending set. I want a pending map, mapping coordinates to information about the tachyon beam at that location. And the information will be how many real beams this virtual beam represents. Because otherwise, there's no way for me to make to say, oh, I've been to this square already. I'd have to. You couldn't look that up in the set because, yeah, okay, all right. I think I have an approach in mind. Now, I think one of the things I said recently might not be true. Because look, this splitter. Oh, sorry, you can't see. I'm looking at the problem statement. This splitter sends particles down here. And I could have another splitter that wasn't at the same height. Let's say this one didn't exist. It's got to be a good example of this already. Yeah, this splitter and this splitter are sort of interesting to me. Because they're both outputting beams into this area. But there's still only actually one kind of virtual beam going down here. This is only visited by one thing above it. And so all the problem cares about is there how many splitters have at least one beam above them? Yeah. I still think this approach is fine. All right, so what are we doing here? I need some types. And I think I want... Is this... Do I want a coordinate to be a data type, or like a new type wrapping a comma, or a tuple, or what? I think just a 2 ints is probably fine. So parsing is actually a little bit annoying. This is something that that comes up a lot in Advent of Code, and I never have a super satisfying solution to it. I have an idea in mind, but we're parsing like a grid. And most of the data in the grid is about things that are part of the grid. There's just this one thing, S, which isn't really part of the grid. Like, I could say, oh, this is a tachyon beam, or this is the designated position that's the start. But if I just return that, if I just parse the grid into something where, like, one position is S, there's all these kinds of invariants that I've implicitly introduced, right? There must be exactly one position that's S. I have to search for it at the beginning of the simulation, find it, replace it with nothing, and then start there. And if I ever run into an S later, it's a programming error. And it would just be much better if the map didn't have a way to represent this is the start position in it. If instead, a side effect of parsing the map is that I also found out what the start position was. And I have at least once in an Advent of Code thing done it that way. And I think I will do it in that way again. Which is to use like writer, I think. So that I have a writer computation whose effect is to produce, let's say, a list of places labeled with start, and we'll say that there should be one or else it's an error, and whose value is the map that we the rest of the grid with basically all the splitter information in it. So let's say new type splitter information. Intensity is an int, let's say, I guess. Which will track how many times a space has been visited by tachyons, both for the beams themselves, how intense the beam is, and for splitters, how much intensity they've been visited by, right? So I think our input should be a coordinate, which is the starting position, and then a map from coord to intensity. I really don't like putting intensity there. It's not... The information that we're implicitly tracking splitters is implicit. So what if I said new type splitter info is splitter info of intensity. Then I could put splitter info here. I think all I really need here is show. Not even that, but... I don't know about making this a new type. I think it's nice because whenever I interact with one of these, I will have to break it apart. I will have to pattern match it, so I'll have to mention the word splitter info, which will reinforce that it's a splitter, not just an ordinary intensity. I think. That seems nice, I guess. So let me look up... Because what I really want is like a writer T of list, probably. Do I want the... I never know if I'm supposed to use the lazy one or the strict one. I think it'll tell you when you go to the docs if you're using the wrong one. Okay. Although the output is built strictly, it's not possible to achieve constant space behavior. Use the CPS version. Interesting. Okay, fine. So writer T... M is the underlying functor. Okay, so run writer T gives you back... Yeah, see, this isn't what I want, is it? An M, which in my case I'm imagining would be list. But, like, list T is messed up somehow, isn't it? Like, you're not supposed to use list T? So here's a proper implementation of the list monad transformer. Well, wait a minute. I don't need... Do I actually need... What if I... Okay. Do I just need a writer that produces a list as its output? Okay, sorry, I had to cut there briefly. I don't know that I actually need a list, a writer T of list, where I have to do like list monadic operations that can interact with the writer ones. Maybe I do just want a writer that produces a list as its output. That's probably true, right? I think I could work with that. Just use traverse across a list. Yeah. Well, okay, give me the CPS one, I guess, because they're saying that's better. Because I can run writer. If I had a writer of list of start locations, or set of start locations, and a list of map entries, I could just run writer that. And I could get that by using traverse on a list of entities which are each a writer for start positions that contain as their value a map entry. Maybe a map entry? I don't actually... The one that I produce the start position from shouldn't have an entry in the map. So maybe... Yeah... It's not quite as clean as I would like. done this in previous years. Because, like, I think there was one last year. So if I grep tel in all of these files, I use the CPS version. All right, so let's look at this file here. What on earth was I doing here? I see. This was simulating a computer. And I was accumulating the output. Okay, so that's not quite the same problem. Oops. 2023... Day 20 looks promising. No. What the hell was happening on this day? Huh. It looks like I didn't finish it, if you look at this send function. Yeah, okay. This must have been the day I quit, huh? Okay. Well, day 3 also had something. Ah! Of course, this is what I want. You can just accumulate 2 monoids of things, or 2 different things in a writer computation, by having the writer compute a pair of them, which will be m-appended pairwise. So if you find the start, you can tell something in the left half. And if you find something that is supposed to be a map start position, you can tell something in the right half. I think I just said the same thing twice, but you know what I mean. If you find a splitter, it goes on one side. If you find start position, it goes in the other. And then you can just... Yeah. This is what I want. Okay, great. Thank you, past Amalloy. So I don't need a writer T. Just writer is fine. I guess I won't import this qualified. Import control monad trans writer CPS. I want writer run. Well, run writer is actually probably part of that's. Yeah. What else do I need? Do I need the writer function? I guess? Let's go look how did I do it in 2023. I used exec writer. I see. If I just traverse over things, traverse will take care of, like, tel is a way of constructing a writer thing, and so is pure, and I don't need any others. Okay, sure. I think this might be all I need. Oh, and I need tell. Prepare of I don't know. File is case run writer parse of lines of file of if we get a single start position and some splitters, we do something. Let's put a typed hole there, I guess, instead of undefined. And otherwise, I guess let's starts, error, bad starts, something like that, where parse rows equals traverse, no, run writer of traverse do I even need traverse? Maybe I just need sequence A. Nah, probably sequence A, right? Grid, where grid is do. Y row zip width, not zip width, just zip 0 rows, X C character, zip 0 row, case C of, if there's nothing there, don't do anything. It's empty, baby. If there's an S there, then we tell kind of annoying to have all these limiters here, but we'll tell the start position YX and empty, not telling any splitters. And if there's a splitter, we'll tell empty and YX. Like that. Does this compile? I mean, surely not, right? Run writer isn't a field. Okay, sure. That's you're right. You're right. Of course it's not. Because writer is just a type alias for writer T stuff. Okay, a million things wrong? It's been a while since I saw this many error messages at a time, and they're so long. Oh, I don't need run writer, actually. You're right. I only need exec writer because I'm not using the value at all anymore. Which means I can just use sequence A here with an underscore. I'll probably have to import that one. What, didn't I? Oh, I have run writer and exec writer twice? Well, let's throw this one away. Put it here, I guess. Case parse aligns the file and parses to exec writer. Sure, why not? Okay, you found a hole. That's nice, I guess. Sequence A is not in scope. Go get that from, I assume, applicative? Traversable? No. Where the fuck is... Does this not exist? It should. It's in foldable. Okay, fine. Okay. So this should be an input. Fine. It's just not finished yet. So you're saying I gave you a list of unit, but you wanted a list of writer. So what is the type of grid? You don't even think it's relevant to tell me this, huh? No, here. Relevant binding include, well, you're saying grid's type is list of unit. I think. What do you mean? So grid is a list of something. Oh, this shouldn't be mempty. It should be pure unit. Don't do anything. Is that not the same as mempty? I don't know. You would think that would be allowed, but we'll see. Okay, there's still this hole here, which is fine. No, this has made no difference. Because I think mempty can be Like, surely there's a monoid instance for writer of anything, right? As long as what you're accumulating is also monoid? Actually, it doesn't look that way. There's no monoid instance for writer T. Okay, fine. But this did not fix anything. You're saying that grid's type is list of unit. But it's not. It's list of writer of this tuple thing, right? How can I get you to tell me what type something has inside of an expression? I think what you can do is give it a partial type signature like that. A type wildcard standing for list of unit. Yeah, but that's not what I want. Okay, so grid should be a list of writer of pair of coord I think. Oh, sorry, that's my phone going off. I have to leave in an hour and a half. Whose return value is unit. This is the type I wish for grid to have, I think. So why does it not have that type, and what type does it have? So here's this type toll. Still don't care about that. Oh, I guess the problem is I'm inside of a list comprehension, and I need to yield a value from that list, and also yeah, actually I think I just want pure on all of these, which I guess means pure here. So, like, I've done the list comprehension part, and now I'm returning one value. And that value will do some computation in the writer monad, which will either tell something or do nothing. So let's say empty then. Oh no, but we determined there is no... Yeah, pure unit. Okay. Is that any better? Yes, that's much better. Now I have this type toll still, but there's only two smaller and different errors that were not here before, so I have fixed something. Oh, and we have a type for coord. We're not just using pairs. Like that. Okay. Now there's no errors left. All we have is a type toll where I just wanted to check what the type of something was. Or I really just wanted to not fill something in. And this actually compiles. There are warnings. which is fine. We're not finished. There should be warnings. And we can now, I think, pretty easily fill this in and test our prepare function. Because I want this to be start, and then m from list of do, I guess. I mean, it's really just going to be a really lame fmap, but I'd rather do it as a list comprehension. Chord s from splitters pure of s, and what is my splitter info? It's splitter info of an int. It's been visited 0 times. There you go. Looks like it parsed just fine. We have splitters for 0 at, the odd numbered indexes on even numbered rows, which is exactly what we expected, sort of. I mean, it's odd numbered at 140 and even numbered at 138, which whatever. The point is that within a row, they're all even or all odd, and we only have some for every other row. So this looks right. And the start position is 070. Perfect. Okay, I'm happy about that. And in fact, I think that I will commit this. But let's see about cleaning up some... There's no warnings. I fixed them all? That can't be right. No, you're lying to me. You're not actually reloading it because the code is the same, right? Okay. Just this one, I get that. Okay, so actually no warnings. Perfect. Did I put in a comment here? And okay, I deleted it. Great. So let's commit this. Day 7 parser. And actually, let me just check. I guess what I want is head.second. No. Can you even head a map? What's in data map? How do you get the minimum key? Because I just want to check that there isn't actually a splitter at 070, because there isn't supposed to be, right? Data map lazy. I mean, strict is probably better, I guess. Yeah, and I'm not using ints. I could use ints if I really wanted to. Yeah, data map strict would be slightly better for me, but it doesn't really matter. Query, probably? Look up, yeah. Do I just need to, Is this like a fold, kind of, in a way, I guess? I guess just... I guess I'll just do head.keys, maybe. Head key m.keys second. Yeah. So the first splitter is at 270, which is what we wanted. It's immediately under the designated start position of 070, and it isn't the actual start position. So that's correct. And I was saying I should use data map strict. Just, because I don't need laziness, and I do expect to use all the values, so that would be better. Let me just make sure that this all still parses. Of course it does. Good. Yeah. Okay, great. So now we can write part 1, I think. Part 1 of start splitters is go of M singleton of start 1, because we're going to keep intensities of all the beams we're tracking and splitters. Let me actually put this argument first. Whoops. Like that, I think. Say we're tracking one thing. Where go of we shouldn't ever have to worry about the list of work items being empty because we're always increasing its size. So how do we get the minimum value from a... Well, it's a map again. It's not a set. And I was just saying I wanted... it is in the data, in the docs. I just didn't go scroll down enough. Lookup min. Actually, I can, okay, lookup max and lookup min are the things I want. Or find min and find max because the map will just never be empty. So let's say last splitter is I guess find min. Yeah, which will, okay. Find max, rather. So we can immediately, just once, ask what is the last splitter in our map. And then we can refer to this in the go function without having to look it up every step. go of splitters, I guess. It's kind of annoying to shadow this, but I think that's all right. Splitters and Q equals let, I guess. Min view, is that what I want? Or do I want delete? Okay, so what's the difference here? Delete find min gives me back the minimum key and the map that is remaining. I guess the difference is that min view gives me back a maybe of it. Sure. But I just know there won't be any maybes, so I'll use delete min. Delete find min? Yes, because I need, okay. Pause intensity Q prime equal find delete find min of splitters. So find the splitter that is highest up in what we're doing. And I guess I want to look up the map. Do I just want to compute the new position? Do I want to immediately move it down and then check what's there? I guess. I think I could move it down by 2 because there don't seem to ever be any blank rows. But there's no reason to do that, and maybe part 2 will somehow insert phantom invisible splitters into the input or something. So let's let pause prime be, let's just define a little function here. Data, move down, what is data? Move down, chord, move down, chord yx equals chord y plus 1 and x. Move down of pause in case m dot lookup of pause. What? Oh, I never remember what order lookup is in. It wants a key and then a map. So the pause and then the splitters of if nothing, then we can just call, and I guess this is kind of a stateful computation where splitters and Q are sort of the state, and I'm doing it the kind of lame way by doing the recursion myself with Go instead of, I don't know, somehow doing it with state in a way that's not clear to me. So if there's nothing there, then we just go the existing splitters and insert into, what order does insert take its arguments? Key, value, map, okay. Pause prime intensity splitters, right? No. Into the Q prime. So if there was nothing there, then we just move the beam we're moving to its new position and leave the splitters alone. But if there was a... What does lookup... I guess I don't need the key, right? And lookup won't give me the key, I think. Lookup... Yeah, and I think you could ask, maybe, to give you back the key. It's not so... Okay, we probably can't. Anyway. Just a splitter info of I. Then we want to update both splitters and like splitters prime and Q prime prime, where splitters prime is m dot, and I guess we can just insert into pause. At pause prime intensity plus I, saying this has been visited by intensity more, this much more intensity than it had previously. And Q prime prime is m dot, I don't really want to call insert twice, it's sort of lame. I want to like union it with another map that has two things. Union, okay, which order? It prefers T1 when duplicate keys are in. Okay, so what the Oh, where m is less than n. So it figures out which map is smaller for you. And then does the more efficient operation. But semantically, it prefers the left side. Which I guess doesn't matter, because there shouldn't even be anything there. There's no way for two different beams to hit the same splitter ever. As long as when I'm doing this, I make sure to combine intensity with whatever is there. Because I might be putting a beam into this space from the left and from the right. So I need to combine those before I fire off the new one. So it's M union with boo, and now the fact that I'm using a new type here is kind of annoying. Combine beams. No. Instance semi-group. I don't need monoid this time. Splitter info where x plus y is x plus y. There you go. And now I can say union with mappend. And then my two maps, one of which is the old Q, and the other of which is do dx from minus 1, 1 pure of coord of, shoot, I need the pos prime pattern matched here. Okay. Like this. Y x plus dx, comma, and the intensity here. Oh, this shouldn't say splitters. It should say Q. So we're producing two beams with a dx of -1 and 1 and the same y, which is derived by having moved down from the beam's old position and then hitting a splitter. Intensite. No, we're looking for intensity. Okay, are we ready to see what the compiler thinks of this? It's usually not impressed. Oops, what? I didn't want to do that. This. You have a lot of complaints, huh? Singleton is applied to too few arguments. Oh, it wants... Okay, fine. Yeah, it doesn't want its key tupled up. I guess that makes sense. Okay, what's next? Find max. Yeah, that's in M. These are pretty trivial complaints so far. Okay, so somewhere I was unclear about whether I was dealing with a splitter info or an intensity, I guess, and that has caused both of these errors. Oh, I guess union with... Yeah. I'm producing a list of entries, not actually a map of entries, so union with doesn't make sense. All right, what's a better way to combine maps? So insertion has insert. Yeah. Combine. Like there's unions, which is sort of, but I don't even actually have a list of maps. So this one's, at least I don't have to go looking to see where I've made the mistake like I do for that type error. The issue is I guess that's fine. Just take this list of two things, turn it into one map, and then union it with the bigger map. Maybe not the prettiest way. So now I have a splitter info. Yeah, so now int and splitter info are getting mixed up in at least one place. So which should be which here? Here, I need to say splitter info again. Noises for semigroup intensity. Oh, I wasn't even combining splitter infos. This whole semigroup instance was stupid. All right, I'll keep it though. So I actually just have intensities, which I can just use plus. Okay. So now it sort of looks like I've written the logic to run these things forever. And I've found the stopping condition, but I haven't actually checked the stopping condition. So I guess I'll use an if here. You don't use ifs very often in Haskell, but this seems like, I mean, there's probably some way to do this as a guard clause. Like if I took this let in and I made it into a where, then I could just use a guard, right? Let's do that. Where bleh. If so, guard that the if pause is the position of the beam we've already dealt with is greater than last splitter pause, then we can kind of just return, I don't know, something. And then otherwise we do this. And what we want is just like the sum of all of the splitter infos, or it's like length of filter visited of the elms of splitters and visited of splitter info I is just I greater than 0. What do we think about this, Haskell? Poslet? Yeah, that's... Didn't delete my let properly. It thinks this compiles. I mean, what happens if I run it? It's a number. It's a number. How many... I mean, does this... Is like, probably we're hitting most of the splitters, right? Is this about how many splitters are in the file? Do I have a good way to check that? I'm not very good at, like, text processing utilities. Like, I can use grep. But I don't know, like, how does grep... Let's find out, man, grep. I don't want to know how many lines match. I want to know how many strings match within a line. Can you tell me that? And it said count matching lines, but that's not what I want. Maybe I could use -O and then feed that to WC or something. Line buffer, no, okay. All right, so what if I said grep hat input? What do you give me? Well, okay, I don't really understand. Okay, so now it's, I don't understand grep's pattern syntax, so I tell it to use Perl's syntax. So it's found these. And then 1711. Yeah, so if we're hitting about 1500 of them, that seems quite plausible, I would say. 1600 even. So let's see what Santa thinks of this one. That's the right answer. All right. It's always satisfying when the first time you run the program, it gives you the right answer. There's a lot of, wrestling with things beforehand, and it can feel tempting if you're used to a language with less well-defined types. Like, I know what I'm trying to write, just run it. But a lot of the time, what you end up running in those languages is not what you meant to write. And, it was a bit of a struggle here, but it was getting me to write what I meant to write. And then it finally stopped telling me I was wrong, when in fact I was no longer wrong. You can't really ask for anything better. At least from the type checker. You could maybe ask for something that lets you write better programs. I'm not stating an opinion on that, but it's nice that the compiler was exactly right in telling me when I had made a mistake, 1 for 1. Okay, so let's get that committed, shall we? Anything I don't want to commit? I don't need this semi-group instance, man. Okay. All right. Well, I mean, I think leaving it there when it's not used at all is just misleading, even though, like, yeah, sure, it could have a semi-group instance. It makes it look like later in the file when I use a semi-group for something, it's for that, when in fact it is not. So, yeah, that I want, and that I want. Okay. All right, so I have how long? Almost an hour left. Let's see if I can do part 2. Oh no, a quantum tachyon manifold. All right. With your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the side of the teleporter to replace the broken manifold, you're surprised to discover that it isn't a classical tachyon manifold, it's a quantum tachyon manifold. With a quantum tachyon manifold, only a single tachyon particle is sent through the manifold. A tachyon particle takes both the left and right path of each splitter encountered. Since this is impossible, the manual recommends the many worlds interpretation of quantum tachyon splitting. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, it goes left, the other it went right. Yes, I think this is exactly what I planned for. You need to know the number of timelines active. So I think we're basically just saying, yeah, that like when it gets here, there's two ways it could have gotten here. It could have gone left and then right, or it could have gone right and then left. And so there are two timelines where it gets here, right? And that's the intensity that I've been counting. So I think all we have to do is like run part one, but just count things slightly differently. So let's... there's a couple ways I could do this. I could extract a helper function called like run tachyon or something that does almost everything part one does, but returns the splitter map. And then part one and part two could both call run timeline or run tachyons and inspect the splitter map and do something different. Or I could parameterize part one by a function and have part two call it. That seems kind of stupid, doesn't it? So let's say, let's rename this function to run tachyons. And here we just return splitters. And it doesn't return an int. It returns, well, let's return just the splitters and not their coordinates. And then part one, of course, still needs to return an int. Part one is of input. Oh, we can write this point free. Is length filter visited run tachyons, where visited this. What do we think of this, Haskell? Would you agree with me that this is a cool function? You would. And it's still 1594, so I haven't broken anything. And then part two is some map fine. Where get intensity of splitter info I is just I. It's a much bigger number. It's obviously much smaller than 2 to the 1500 because not every timeline touches every splitter. This is, I would say, a plausible size. It's too low. It's too low. Okay, I hate this. So is there something wrong with my implementation or with my idea? I'm not sure. All right, let's go look at the problem again and try to understand better what this many worlds interpretation means. Oh, I guess I'm not quite counting the right thing, am I? God, don't tell me I need to add 1. That would be pretty funny. I don't think it's right, but... The issue I'm thinking of is, okay, let's say a tachyon gets here. You know, how many times did it get there? I don't know, let's say 5, just make that number up. It got here 5 ways somehow from above. I don't think that's true. In fact, I think no tachyon can ever get here. But for the sake of example, let's say something got here 5 times. Then we reach this and say, oh, you've been visited 5 times. Great. But there are then 10 timelines active, right? Those 5 timelines could have gone left, or they could have gone right. So am I even tracking this right for tachyons up higher or not? Like, what if... I think it's only the last tachyon visited where I'm doing this wrong. Or the last splitter visited by a given tachyon, I should say. Because this one, let's say somebody hits U. Better example, U. Let's say 5 guys got to U somehow, although it looks like it's only 1. Well, let's say 1, because that's what's actually true. 1 tachyon gets here. So I mark this as visited once. But this isn't even important. I don't even care how many times this has been visited. I need to know that... Yeah, I don't care about the splitters at all. I just need to know about the beams that are still pending. Right? Because each of those actually does represent a number of timelines, a number of ways I could get to there. Okay. So I shouldn't necessarily... the helper file I extracted, the function I extracted, is not quite the right one. But let's just say it returns a tuple. The Q... the queue of pending things and all the splitters, the list of splitter infos. So both of those, I think we can, okay. We can just do that. Like so. And then here, say, we're only looking at the splitters. And here, I'm only looking at the intensities. And just add them all up. This number looks smaller. 3, 6, 9, 12 digits. 3, 6, 9, 12 digits. This number is smaller, and my old number was too small. How dare you? Am I handling recombining of timelines wrong? I bet I am. Right? Because I was just tracking intensity. But we're actually being asked something like, when suppose this, the first two rows, were the entirety. Oh no, this would be right. There should be 4 timelines active by the time we get here. And I believe that's true, because we would have 1 timeline that goes here, 2 that go here, and so their intensity gets combined into 2. 1 from this side and 1 from this side. And so we'd have a beam going down this way with intensity 2, and 1 going this way with intensity 1. Now if we hit this with 2, we are tracking. We're putting a 2 here, not a 1 in that case, right? We must be. There's no way the number would be so large otherwise, but let me just double check. If we hit a splitter, yeah, we're using the same intensity that we already had on both the left and the right. And we're unioning with plus in the existing queue, so that if we catch something else on that side, we add to it instead of overwriting it. Well, we could build a very small tachyon accelerator ourselves, I suppose, and just run it and see if we get the right answer or the wrong one. Like run tachyons of coord 0 I don't know 6 should give me plenty of room. And then where are all the splitters? Does it want a map? It does. Kind of annoying. M from list of C splitter info 0 for C from. Okay. So where do I want all the splitters? Let's say at 2, 6, directly below the starting point. 4, 5, just to the left of that one and below. 4, 7, just to the right of it and below. And I think that's enough. That should be reproducing this. Okay. 1, 1, 2. So that's right. Although I would have expected 1, 2, 1. So let's try to make sure that my notion of intensity maps exactly to this notion of timelines. My thought was we're tracking basically how many beams are here, assuming that it splits into two beams of equal size. So when we get, let's say, here, how many ways were there to get here? 2. It could have gone left-right, or it could have gone right-left. And that means there are 2 timelines that get here. And it also means there was intensity 2 heading into this splitter, according to my intensity theory. And we'll end up spawning an intensity 2 thing here and an intensity 2 thing here, which will each be combined with an intensity 1 thing from the far side. I guess, okay, let's add one more row to my little toy particle accelerator. So we also have just to the left in call, so 6, 4, and then 6, 6 directly under where we started, and 6, 8. So that should represent this. And I expect one timeline here, one timeline here, and then how do we get to this spot? We could have gotten left, left, right once, or either of the 2 ways we got here. So this should be a 3. Oh, is this Pascal's triangle? I guess as long as it's... Yeah, that makes sense, actually. As long as it's a complete tree. Once we start having missing spots like this one, it won't be anymore. But so it should be 1, 3, 3, 1, right? Because there's 3 ways to get here as well. So that's what I expect when I run this. And it is. Okay, so what if instead of run tachyons I said part 2? 8. Well, that's right. Okay, well, I guess what I can do is just take the example input as is and make that into another test file and just see if I have that right at least. Oh, it's not going to paste well. Oh, it is. Okay, great. I thought it might not paste very well. So if I say read file of, I already forgot what I called it, test-input.txt, part 1, let's do that first. What do you mean? What directory am I in? Oh, am I in like the source? What? Oh, I called it text input. I spelled it wrong. So part 1's answer is 21, which I assume is correct. Yes. Tachyon is split 21 times. Now part 2, there should be 40 timelines here. But there aren't. There are 28. Well, that's very interesting. So that's good, at least. It means a relatively small input will reproduce my problem. Oh. I have an idea. When I move a beam directly downward, I bet I'm not checking whether there's already another tachyon there already. When I split to the left and right, I'm checking and adding with what's already there. But it's possible, like I'm moving these beams one at a time, and I thought, oh, they'll always just collide and that'll be fine. But the beam, if there were a beam here and a beam here, both moving downward, I always do them, top to bottom, left to right. So I would do this one first, move it down here, and split it to these positions. Then the next one I move would be this one. And I don't think I ever just wrote code to merge the two of them. So I bet I'm overwriting the intensity that was here with the intensity that was here instead of adding them. So I just need like insert. I need. Yeah. I'm just inserting into the queue the new intensity. I need I think I just need insert with plus. Is that it? Hello, can I type? Insert with, here we go. Insert with plus, yeah. Okay, that's probably it. Insert with plus. Problem solved? It's a bigger number. Is it bigger than the old wrong answer I tried? I don't know. I can no longer see that easily. 15359, 1565. Yeah, it's bigger. I thought I had one that was like 1.8 something and it was still too small. Yeah, this one. Is plus what I want? If there were 10 timelines to get to a place, and I've added 5 new timelines to get to that place, there must be 15 timelines to get to that place. So that seems right. All right, I'm going to insert this. I think it must be too low already because I tried a smaller number and it was too low, or a bigger number, but maybe this has more digits. 3, 6. I'm not sure. Oh, that's the right answer. Okay, great. And all of that with, 20, 30 minutes before I have to leave. Yeah, I think I probably just want to commit all of this, but let's see. Yeah, so that was the bug in part 1. That didn't matter as far as part 1 was concerned, but did matter when I tried to use that information for part 2. All right, that's good enough. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.